Now, this is a problem that really deals with wording issues when you deal with time value of money. So, here we go. It says, answer the following questions. The A part says, would single investment made today, earning 12% annual interest, will be worth $6,000 at the end of 6 years? The B part says, what is the present value of $6,000 to be received at the end of 6 years if the discount rate is 12%? And the C part reads, what is the most you would pay today for a promise to repay you $6,000 at the end of 6 years if your opportunity cost is 12%? And the D part, they want us to compare and contrast our answers. Now, the reason I gave this problem is because all these parts of the problem, they all sound much different. In point of fact, the solution to each of those questions, A, B, and C, are all the same. This is a lump sum cash flow, and in this case, the unknown is in the present. We use our present value interest factor. In other words, how much is this $6,000 worth today? The A, B, and C part now, they sound much, much different, but in fact are all the same. The unknown is equal to your lump sum cash flow you know out in the future, $6,000, and you multiply it by your PVIF with n equal to 6 and I equal to 12%. Again, you use PVIF because the unknown's in the present. If you look up your PVIF at 6 and 12%, you'll find an interest factor of 0.5066. Multiply that by $6,000, and you get $3,039.60. To answer one of these questions, if you put this much money in the bank today, and it earns 12% interest every year for 6 years, 6 years from now, you'll have exactly $6,000. To solve this problem in a calculator scenario now, future value, and again, future value and present value buttons on your calculator now, that's where you put lump sum cash flows. And in this case, we know the lump sum cash flow out in the future, that's $6,000. That's how much money you want to be able to take out of the account, out of the investment, things like that. That's a negative $6,000. N's equal to 6, there's 6 time periods. I is 12% discount rate. Solve for your present value, and you get $3,039.79. Now, just a little calculator deal here. If you made this number a positive number, this number, the answer will turn out to be negative. And so when we made this negative, this turned out to be positive. Now, that's something that always happens when you do time value of money on a calculator, and you have to get past that and learn how to think about it. In this case, we're talking about, we're wanting $6,000 5 years from now for some expenditure. That means $6,000 is going to be an outflow, a negative number. How much do you have to put in the bank today? That would be an inflow into the account. That's a positive number. But nonetheless, this is how you would solve the problem with your interest factor tables. This is how you would solve the problem on a calculator.